Antarctica, a land of ice and extremes, just delivered a shock to the scientific world. The Hectoria Glacier, once a massive stable river of ice, collapsed with unprecedented speed, vanishing from satellite images almost overnight. Researchers led by Naomi Ochwat at the University of Colorado Boulder stumbled upon this dramatic change while reviewing satellite data. The glacier's front, stable for years, had simply disappeared, replaced by open water and scattered icebergs. This wasn't a slow melt, but a violent, rapid disintegration, an event that forced scientists to urgently investigate what went wrong. The scale was staggering, a familiar coastline redrawn in days, not centuries. The collapse raised urgent questions about the stability of other Antarctic glaciers and the future of our oceans. The Hectoria event is more than a story of melting ice. It's a warning that change in Antarctica can be abrupt and devastating. Understanding this collapse is crucial for preparing for the future of our planet. What stunned scientists most was the speed. Hectoria Glacier lost nearly half its mass in just 2 months in early 2023. The glacier's front retreated 8 kilometers, shattering into a flotilla of icebergs in a matter of weeks. At its peak, the glacier was retreating faster than a person can walk, 2.5 kilometers in just 2 days. This was not a slow, predictable process, but a chaotic, violent collapse. Instruments even detected glacier quakes as the ice tore itself apart. The event shattered previous records and forced a rethink of how quickly glaciers can respond to environmental change. Scientists had theorized about such instability, but had never witnessed it on this scale. The Hectoria collapse is now a benchmark for how rapidly glaciers can fail under the right conditions. It's a wake-up call. Glaciers can go from stable to catastrophic with little warning. The scientific community is now urgently reassessing the risks facing Antarctica's other massive glaciers. To grasp the impact, consider the glacier itself. Hectoria once covered 115 square miles, the size of Philadelphia. Located on the fast-warming Antarctic peninsula, it was a slow-moving river of ice, hundreds of feet thick. For years it seemed stable, but warming air and ocean were quietly thinning it from above and below. This region acts as an early warning for the rest of Antarctica. Changes here often foreshadow continent-wide shifts. Hectoria's sudden collapse is a signal that critical thresholds are being crossed. Imagine half a city-sized block of ice breaking apart and drifting out to sea in weeks. The loss has reshaped the Antarctic coastline and highlighted the vulnerability of these frozen giants. It's a stark reminder of how quickly stability can give way to chaos in a warming world. The secret to Hectoria's collapse lay beneath the surface, an unusually flat bedrock, or ice plain, below sea level. As the glacier thinned, it reached a tipping point. Its front edge lifted off the bedrock and began to float. Once afloat, the glacier's base was exposed to warmer ocean water, accelerating melting from below. Water carved deep crevasses upward, while surface meltwater seeped down. When these cracks met, the ice shattered. The combination of a flat, below-sea-level bed and the going-afloat process triggered the rapid collapse. This mechanism reveals how certain glaciers can fail catastrophically once they lose their grip on the land. Scientists now recognize these hidden weaknesses as critical risk factors for future collapses. Hectoria's fate has redefined our understanding of glacier vulnerability. Scientists pieced together Hectoria's story using cutting-edge satellite imagery and seismic data. By comparing images before, during, and after the collapse, they mapped the glacier's retreat in detail. Radar satellites revealed changes even through clouds and polar darkness, while seismometers detected glacier quakes as ice ground against bedrock. These signals proved the glacier was grounded before it broke apart, meaning its loss directly raised global sea levels. The combination of visual and seismic evidence provided a complete picture of the collapse. This detective work shows how technology lets us monitor even the most remote, dynamic parts of our planet. Hectoria's collapse is now a case study in how science can reveal and explain Earth's most dramatic changes. Hectoria's collapse is a warning for the world. Many Antarctic glaciers rest on similar flat, below-sea-level beds. These hidden vulnerabilities mean other, much larger glaciers could also be at risk of rapid, catastrophic failure. The Antarctic ice sheet holds enough water to raise sea levels by nearly 60 meters. Even a small increase in ice loss could devastate coastal cities. The speed of Hectoria's retreat suggests current sea level rise projections may be too conservative. Scientists are now mapping Antarctica's bedrock to identify other glaciers at risk, improving our ability to predict future changes. The fate of distant ice is directly linked to the future of millions living near the sea. Faster than expected collapses would worsen flooding, storm surges, and threaten freshwater supplies worldwide. Hectoria's story is a global issue, one that demands urgent attention and action. The collapse of Hectoria Glacier is a stark message. Earth's frozen regions are changing in ways that are sudden and profound. Glaciers are not just remote wonders. They regulate climate, store fresh water, and reflect sunlight. Their health is a direct indicator of our planet's balance. Hectoria's story is also one of hope. Science and technology allow us to witness, understand, and respond to these changes. This knowledge empowers us to adapt and make informed choices for the future. The ice is sending a warning. Our actions have global consequences. The fate of Antarctica's glaciers is tied to our own. We must listen and act before more of our world's frozen giants are lost.